Okay, this one doesn't even ask us to graph. We just need to find that explicit equation. And if you find the explicit equation, then writing the domain is going to be easier. Okay? First of all, the domain of f of x, can you see that x can't equal negative 3? And the domain of g of x is everything. So, g of f of x. If I want the explicit equation for this, all right, I'm going to just say let y equal g of f of x because there was no y. Don't know. I feel like this would be one that on the exam, if you didn't write that I don't think they would take off an E2, but just being careful. Let y equal g of f of x, then y would equal g of, for the explicit equation, I get x plus 3 gets thrown inside of g. And then, this isn't the prettiest equation, but what does this become? This is, whenever you plug into g, first of all, it gets squared. So x plus 3 gets squared, minus 4 times 1 over x plus 3. This is the equation. Can you see that this still has a non-permissible value? That x can't equal negative 3. Any other non-permissible values in this one? No. Any other x value you plug in is fine. This would be enough. If they actually wanted you to graph this, I would simplify this to a rational equation and use what we learned in chapter 2. So for example, I would write this as squared would have this on the bottom, minus 4 over x plus 3. If I wanted to combine these with a common denominator, I'd multiply top and bottom of that by x plus 3, giving me a common denominator of x plus 3, x plus 3. And on the top, I would have 1 minus 4x plus 3, which would be minus 4x minus 12 plus 1 minus 11. This is group 3. You'd have a vertical asymptote at x equals minus 3 for the non-permissible value. You would have a horizontal asymptote at y equals 0 because the degree is an x squared on the bottom, which is bigger. You would have an x-intercept at negative 11 over 4. You would have a y-intercept at negative 11 over 9. You might have to find another nice point and you draw your graph towards the asymptotes. But they didn't ask us to graph. So instead we'll make a happy face and just go on to the next question. Well, I'll give you the ones you can do. Oh, we still have B to do too. Thank you. B says find f of g of x. This is interesting. So I'm going to let y equal f of g of x. So then y would be equal to f of, and g of x was x squared minus 4x. And then what does f do? It says whatever you plug in goes on the bottom. Oops. So the x squared minus 4x will go there, and then you add 3. This is interesting. In fact, on the bottom there, I can factor this to be x minus 3, x minus 1. The non-permissible values here is that x cannot equal 3. X cannot equal 1. What is my domain? Well, if those are non-permissible values, they're not allowed. And here's the interesting thing with the composition of functions. It didn't come up in the first example, but it kind of comes up a little bit in the second one. You might be tempted, and this would be wrong, because look at the original. The original was like, hey, your green function, the domain x can't equal -3. So should I add to this one that x can't equal -3? No. Tempting, but no. Okay, why? Well, we do g of x here first. I'm going to highlight that. Was there anything not allowed here? No. Then that got put into f of x. Not just an x. So our only domain is that x can't equal 3 and x can't equal 1. But you do have to be careful with the domains. Had question A, right? Here I have, at this moment, I have a non-permissible value. X can't equal -3. That would follow through, even if later it goes away. In this question, you have a moment where x couldn't equal -3, even if that's simplified later. So we're having to be careful with domain and range in these questions. Because if something's not allowed early, it's not allowed later either. Okay, so with that, question 6D, and I put a star beside that one, so it's a little bit, makes you think, I think. So make sure you take a look at that and comment and ask questions if you do have any. And